Hello friends, welcome to edenbrain.com. We'll see today Introduction to Finite Automata. Finite Automata. And that will be denoted by FA. FA is a short form of Finite Automata. Now let's see what is Finite Automata. Finite automata is a machine which accepts some strings or rather rejects it. So means this is a machine which will help you to solve a problem, right? So now this finite automata is actually, I can say, a recognizing device. So if there is a grammar, so grammar will be a generating device. So grammar is a generating device, and then the automata it's recognizing device. So it will recognize the language which is generated by the grammar. So before I start, what is the recognizing device and what is the generating device, I will let you know about the finite automata's type. So finite automata is actually divided into two types. The first type is without output, I can say, and the second type is with output. So there are two types of devices. One will be without output and second will be with output. Without output category consists of non-deterministic finite automata and deterministic finite automata. So these are two types of automatas where we don't have output, but we can recognize whether the string is accepted or not. Now here we can recognize the string as well as we can see the output also, and these are Moore and Mealy machines. So this is Moore and that is Mealy machine. So understood? So this is very simple about finite automata. Now we'll concentrate on a DFA first, because constructing DFA is one of the interesting and one of the challenging tasks, I can say. So let's try to see what is DFA. So now let's look at the mathematical definition of finite automata. Finite automata is a 5-tuple machine, I can say. It's a 5-tuple machine and it is denoted by, let's say, M, which consists of the 5 tuples. The first tuple is Q, then there is a summation, then there is a delta, then there is a starting state, and then there is a set of final states. You can see that this is a mathematical representation of a finite automata, which is, I can say, it's a set of states, right? Set of, you can say, even a finite states. That will be much helpful. Then this will be the input alphabets, like 0 and 1 for binary, and maybe if it's an English language, then it's A to Z, like it's alphabets. And then this denotes the transition function. This is a transition function, right? Now what is transition function? Transition function delta is denoted by, see here, a transition function delta is denoted by Q into sigma, which implies Q. It means on any state, if there is an input alphabet as input, if there is an input in terms of alphabet, then I will go to the next state or any state. So where I will reach? I will reach to any one of the states, right? And in terms of NFA, it might be more than one states, right? So let's discuss about NFA and DFA afterwards. So this is what a transition function is denoted by. Next we have S. S denote the set of start set, and I can say the mod S is always 1, because always set of start set consists of only one element. right? And that can be called as a singular set also. Then the F denotes set of final states, you can say. So there is a difference now. It was a state, now it's a state, set of final states. So mod F will be definitely greater than or equals to 1. Okay. So this is what a mathematical definition of finite automata. Now in the next chapter or in the next video we will consider DFA, difference between DFA and NFA in more depth.